In this video, in the second part of our runner game, we are going to implement the movement to the left and to the right. So it looks like this. When I will press the left arrow key or A key, I will move to the left. When I will press the right key or D key, I'm moving to the right. So this is creating this nice movement. Okay, let's get into it. We need to move the player left or right by pressing the keys we will choose. I will go with the keys A, S, D, W and arrow keys. So when I will press the A key or the left arrow key, the player should move to the left side. When I will press the D key or the right arrow key, then it should move to the right side and back and forth. So it will be moving in these three rails. Okay, so how much we need to actually move? We need to get the target position. So we will be changing the X position because the X position is this left to the right movement. The current X position is currently minus 0.5 and that's a middle position. But if we want to move the left side, we need to move to, let's see how much we need to move. Actually 3.5 I see here. That will be, I think, the position we want to go to with. So minus 3.5. We'll be moving to the left rail and moving to the right rail. So from the 0.5, I suppose this will be 2.5. Yeah, this will be 2.5. Okay, so to the moving to the right side from the 0.5, we'll be moving to 2.5, and moving to the left side, we'll be moving to minus 3.5. So how many units we need to move left or right? We need to move 3 units. Okay, so going from the minus 0.5 to go to the left position, we need to go to minus 3.5, which is 3 units. And going from the 0.5 going to the right side is also 3 units to go to the 2.5. So to 2.5. Okay, so that's the distance we need to move. So when we are in the middle, going here, 3 units, and going here, minus 3 units. Okay, so that's the idea. Now we know how much we need to move. Now we need to just implement it in the code. So get the player please back to the original position, which is minus 0.5 on the x-axis. Go to your code, to our player control. We'll do here some cleanup. We'll create a void, and here this is the rotation of the player. So handle, create here new function, call it handle rotation. All right, and get this code from here and get it to the handle rotation and get it handle rotation. Also, I will change the indentation of this file so it's easier for you to read. I think it's better for you when the space indentation will be 4 spaces like this. So there's 4 spaces. Distances when we are creating the method and when we are indenting the code. Okay, so we have a handle rotation. Now we need to handle the movement. Okay. So a couple of things we need to store here. I'll create here a new private variable. This will be vector3, and it will be my original position at which I am standing right now with the player. So original position, and my original position, I will create here start a method like this, and I will get in my original position will be my position at which I'm standing when the script is run first time. So this will be my original position stored here. Now I will create float variables, the target positions in which we need to move. We know these positions are minus 0.5 is the middle line, then minus 3.5 is the left line, and the right position is 2.5. That's the original middle position, going 3 units, going minus 3 units, right? We'll be storing these units, these values in the array. So I'll create here a new private float array. I'll be storing this position. I will call it lanes. Lanes or lines or lanes, whatever. Okay, so we have a lanes. And also we will be storing here how much will be increment of our movement, how much we want to move. And we talked about it, that we want to move 3 units. 3 units left or right. So this will be our private float, and we'll call it, how I want to call it, movement increment, or you can go with a move step. Move step. This way, and yeah. Okay, so we have move step. Now we will initialize our lanes. So m underscore lanes equal new float array, and we'll initialize this position. So our middle position is this will be, actually we need to store it somehow. I will create here We'll do it like this: float, and I will call it a middle x position will be our initial transform position x. Okay, or actually maybe I can use as a middle position or transform position x. I don't need to create here an additional variable. Or no, let's keep it in variable, it will be very useful. Yeah, let's call it middle x will be our original transform position x, which is minus 0.5. So I will store it here like this. Our leftest lane is our middle x position minus move step. So middle x minus move step, comma, and the right position is the middle x position plus m move step. So if the middle x here, our original x position, is minus 0.5, and we will initialize the move step here in our coding editor to be 3, going middle x plus move step will be a minus, actually 2.5, and middle x minus 0.5 minus move step will be minus 3.5. So this will be lanes. These positions will be keeping there. Okay, and let's write here semicolon. Okay, so I guess here we have everything. Okay, original position lanes. We'll just initialize it in our coding in our Unity editor. So go to the player game object, scroll to your player controller. Actually, I moved the player control up here so it's easier for you to see on my player controller. And we have a move step, and move step will initialize to 3 units. Okay, so make sure this is 3. Now, back to our code, we're going to create here a function to handle the movement. So I'll create here void and handle movement. All right, and call handle movement here. Okay, so we know that we want to handle movement whenever we'll press the keys, arrow keys, or A and D keys to move left and right. So we'll write here if input get key down, and you're looking for the key with the key code. So key code will be left arrow key, or equivalent to this would be pressing the A key. So copy this entire thing, paste it here, and this will be A. All right. So this will be the movement to the left side. Okay. Now let's write here else if. It will handle the movement to the right side. So it will be the right arrow, and it will be the D key. I'll format my code this way. Okay, so this is the movement left, and this is the movement right. Okay, we can also debug like here. Log. Actually, we'll create here one more function. Okay, so create a function void move to lane like this. All right, and it will be moving to the lane, and we'll be moving here like this. We'll create a parameter called direction, in direction, and it will be either -1 or +1. Okay, and here we will call this, when we're moving to the left side, we will call here move to lane. So when we're going to the left, it will be -1, and we're going to the right side, it will be move to lane +1. So if you imagine we have this array where we're keeping the lanes, where the middle position is -0.5, the right position is 2.5, and the leftist position is -3.5. If we are in the middle and we will press the left arrow key, this should move to the -1 index basically. So the indexing in the array is following 0, 1, and 2, right? So by moving to the lane from the middle, when we're going to the left side, our current index at which lane we are is a 1, -1 is 0. So we should move to the 0 index, which is, this will be this coordinate. And when we'll move the +1, we'll go to the index 2. This will be coordinate 2.5 for the x position. That's the idea behind it. Move to lane -1 and move to lane +1. Okay, so now we need to just finish the implementation of move to lane. Also, we want to make sure that you're calling this. So debug log here and debug log your direction. All right, let's save this. Go back. Play the game. Click your console. Click your right, and you should see 1. When you click the left, you should see -1. Okay, I'll shut this down and get back to our code, and we'll be handling the move to lane. First, we'll create a variable, private, float, and this will be the target position x in which we want to move to. So let's write here m_target target position x. Okay, and we'll initialize it to our initial transform position. So we can just write here like this. Our transform position x will be the m target position x, and this will be also middle x position. That will be that's basically the target is our initial position at the beginning. Okay, but when we'll be pressing the left or the right arrow keys, or A key and D key, our position will change. Okay, so let's go to the move to lane, where we have a direction. We'll get here for loop. We'll get here int I is equal to 0. I is equal, or I is less than our lane's length, and we'll increment I++. So here what we want to do is increment over all our lines and check if we are in the position. If we are in this position and we should move, then we'll choose a new target position. Okay, so what I mean by that? I'll write here if statement. If mathf, we'll use here mathf, and we'll use here approximately method. If the target position, so m underscore target position x, is the same as our lane position, m underscore lanes at I index. So if we are in the position, if we are in a lane, and we are pressing the left or right key, then we can choose the new index, and we'll choose the new index like this: int new index equal math.clamp. We want to clamp the position, so we will not move out of the boundaries of indexes, because we can move only to the positions as we have an array. Middle position is 0. Right position, or actually we have like these indexes with our position minus 0.5, then we have a 2.5 and minus 3.5. So you can see we have only these indexes. So when we are at index 1, we can go to the 2, but we cannot go to 3 index. So that's why we are using this clamp. So we will be staying only out of the boundaries. So if I am in 2 position and I will increment here +1, this will not change it to the 3, but it will stay 2. That's why we'll be using the clamp. So that's how we will choose the new position. We'll be clamping I plus direction and m lanes length -1. Okay, and here 0, like this. Okay, you can also read the description here of the clamp. So the current value where we want to move. So this we want to move I plus direction, so I plus 1 or I minus 1. And here what the minimum value can be and the maximum value can be. Okay, the clamping value when we'll cross the maximum, the value will become the maximum. Okay, so that's how we will choose the new index, and then we will choose the new target position. So m underscore target position x is equal to the new index position. So it will be m lanes at the new index position, and we'll break from this for loop this way. Okay, so now we should be choosing the new target position, so we can actually move here. Not here. Let's do it here in update under handle movement. So we'll choose here the new position, var new position, and this will be the new vector tree, and we'll use here our m target x position, and y and z will not changing, so we will keep it as we have it. Transform position y and transform position z, like this. Okay, so it will be our new target position, and we will use here a method called move towards. So our new transform position equal to vector 3 move towards. We need to provide our position where we are currently standing. So that's a transform position. The position we would like to move towards to. So that's our new position. All right. And then you need to provide the size of the increment, how fast basically you want to move. So the maximum distance you want to move. And this will be, actually we need to get here some value for our move speed. So for now, just write here delta time, like this, and we will introduce here the variable called move speed. So there will be basically how fast we want to move from line to line. So here we will create a new serialized field, private float, and this will be move speed. Initialize it to the 1. value, and here will be move speed multiplied by delta time. So it looks like this. Okay, now you can save this. You can go back to your code and we can try it out. Okay, let's play the game. And you can see we are moving, but we are moving very slowly. So what you need to do, just increase the move speed, right? So they get here 10, let's say. So move speed will be 10. And now we can move. Perfect. Even more. I will go with 15 maybe. So I will choose some big value. Okay, perfect. So this works just great. We are not getting out of the boundaries. When I'm on the left side and I'm pressing the left key, I'm staying there. I'm not going more left. And when I go right side, I'm pressing the right key and I am not going more right. So this works perfect. I can move from line to line. I can change the direction in between of the lines, and this works. This works good. Okay, let's shut this down. One thing here. Now let's get back to our code. Here, this original position, in the end, I'm not using. I thought I'll be using it, but I don't need original position just yet, maybe. So I will just remove this original position, and we have this very short code. Okay, one thing here. When you will run application, and when, let's say, you want to just hold the right key, you will hold the D key or right arrow key, and you will just move one line. You're not continuing to the next line here, because we are just registering this key down once. If you want to register as you are holding the key, and while you are holding the key, you want to move right side, instead of calling here get key down, you can just call here get key and introduce it everywhere. Okay, but this will introduce a small issue with our code. Let's save this, let's get back. And what the issue will be is simply when you will press it, this will be registered multiple times, so you will be moving more. So I will press it once, and you can see I'm going immediately the entire length, and it's very hard to get to the middle line, because basically when you press the key, this is called multiple times, not only once. So if you want to just register it in some time intervals, so we don't want to register it continuously, we need to introduce here some cooldown for our keys. So I'll do it like this. I'll create here a new variable. Under the move step will be serialized field, private float. I will be calling it move cooldown. Cooldown. Okay, let's say it will be initially 0.1f, and we'll create here also a new private float variable, and this will be next allowed movement. Next allowed movement, like this. Okay, and initialize actually to 0. So next allowed movement will be 0. Okay, now I'll be pressing the key. So when we'll be moving here in a move to line, we will be registering here. We'll be creating here a new value for our next movement. So we'll write here m underscore next allowed movement equal, and this will be the current time plus our movement cooldown. So movement or move cooldown. So we can move at this time now, next allowed movement. And here, as we'll be handling the movement, we'll write here if statement. We'll wrap it in the if statement like this. And we want to move only and only when the time now, so time is greater or equal next allowed movement. Okay? And now we should register this in 0.1 intervals. We should be moving in the 1 0 point intervals. Okay, then you will save this. So place this here as we are moving, and this as in the handle movement. When you will get back now and you will run the code, you can just move into 0.1 intervals. So when I will be holding, you see, I can now press and I will just go into the line. When I will increase the interval, so let's say interval will be 0.5, a little bit bigger, I will be holding the right key. I will stop here for a second, and I can move again after 0.5 second. Okay? So this is not very reactive, because I can only move in a 0.5 intervals. I think 0.1 was quite good. So I can still just press key, or I can hold it and I will be moving from line to line. So that's very good. So this is the cooldown, cooldown 0.1. Okay, this works great. We can move, and it's starting looking as the actual game. Okay, that was the part 2. The next part will be handling jumping of the cube. Okay, so I see you next video. Cheers.